Hi dear students. So in the previous two lectures we have discussed about units and measurements, the second chapter in class 11, and there we have discussed mainly the dimensional analysis. In the first part we have done what is dimension, okay, and how we can able to find the dimensions of different kind of physical quantities, and then we have done application of dimension and dimensional analysis and some numericals in the second video. Today we'll do another important topic of units and measurements, that is significant figures. Significant figures. So the idea of significant figures you have got earlier, okay, but what is it? What is the need of this significant figures in units and measurements? So by the name significant, see, what does it mean? It means something which is important for us. Okay, assume now it's the season of mango. Assume 10 mangoes are given to you, and out of 10, if 2 are rotten, so you will just throw it outside and you will take the significant number of mangoes you have got, that is 8. So here significant means which is important for you, which is valuable for you, which is easily accessible for you. Now, what is the need of significant figures here? See, whenever we represent a physical quantity by Q, we represent it by N into U. What is N? N we have told it is magnitude. Magnitude means it's a number and U is the unit. Okay, so what is unit? What type of units are there? What is the unit of different physical quantities that we have discussed earlier? Now we have to talking about this n. Talking about this n, that is a magnitude. Now you can say, sir, magnitude is magnitude. What is the problem with that? I'm giving an example. Assume uh, it's a rod, and above the rod one more stick is added, and there one flag is there. Okay. Now it is told what is the distance of the flag, the topmost point of the flag from the ground. So the length of the rod is given to you. Assume it is 2.4, not 2, let's little more. It's 5.42, and this length, assume it is 1.235 meter. Definitely it will be meter. Now you will say, sir, it's a very easy thing. Add it. 1.235, 5.42. Add it. So 5, 5, 6, 6. So, sir, the total height of the topmost point of the flag from the ground, it will be 6.655. I'll say it's wrong. Now you'll tell, sir, what is wrong? Add it. 5, 5, 6, 6. It's right. We have done it from very early ages, from class 3, 4, 5, 6, 7, 8. Now you say at class 11 it is wrong. Why it is wrong? That we have to see in this chapter. Okay. Everyone will tell, sir, this is absolutely correct, but I am telling it is wrong. Why I am telling it is wrong? That we have to see here. Let's see. Okay. Now, what is significant figures? Significant figure is whenever we have to write the magnitude of any measurement. Okay, so there will be two type of digits are coming. Assume one digit is coming 6 point or 64.2. 64.2 meter. Assume you have measured a length. The length is 64.2 meter. So here when we are talking about this 64, it is the perfect value. It is a reliable one. We don't make any problem with that 64. It is, we are very much confident about that. So this is called as reliable digit or reliable digits. Okay, so two reliable digits are there, and number this two. After point what digit is there, we are not very much sure about that digit. Okay, so this is known as uncertain digit. Okay, so reliable and uncertain, using this two we are representing the magnitude of any physical quantity. Now this sum of reliable and first uncertain digit is known as significant figure. So sum of reliable and first uncertain digit, we can say significant figure is equals to reliable plus first uncertain digit. So here you see, if I want to find the significant figures in this digit, so here reliable is 2, first uncertain is 1. Okay, number of digits if I have seen, so here the number of significant figures are 3. Here the significant figures are 3. Now the problem has come, if I have given a 0 here, if I have given one more 0, is there any change of the value? You can say, no sir, the value is same. But if I have given the zeros here, then the number of significant figures are changed. If I have given a 0 here, let's see how this number of significant figures are changed by coming of 0 here. Okay, let's see. So to learn about the significant figures of a number, we have to know certain rules. But I am not telling it just like a rules. You don't think that whenever we are talking about rule, so rules, the word seems to be little bit of harder, something that you have to remember lots of things, that a plus b whole square equals to a square plus 2ab plus b square, sine square theta plus cos square 3 equals to 1. So this type of rules are not there. Okay, it's a very easy rule. Try to understand. I think it is not like that you have to remember, you have to memorize. If you understand it and practice some numericals, then the rules are very easier for you. Let's see what rules we're gonna discuss here. Rule number 1, to find the number of significant figures. So rules number 1, it is told all non-zero digits are significant. All non-zero digits are significant. That means if I have written a number 5, 2, 3, 4, all these are non-zero. So we can say here significant figures are 4. If I have written 5 to 0.34, here also all digits are non-zero. Here also the significant figure is 4. If it is 3.3, 5, 6, 7, 8, etc., etc., it's a long number. All the digits are non-zero. So significant figures 1, 2, 3, 4, 5, 6. If it is 2, significant figures is 1. Okay, so all non-zero digits, okay, so forget about 2 here. it's 2.22, so here it is 3. All non-zero digits we have to take in our measurement, okay, and that should be taken as significant. Okay, all non-zero digit we have to take as significant figure or significant number or significant digit. Number 2, the problem is made by the zeros only. Okay, so it is told all zeros between two non-zero digits or two significant digits are significant. What it is told? All zeros between two non-zero digits or two significant digits are significant. Example, assume if I have given an example 5 0 0 3 2 4, whether these zeros are significant or not. See, they are in between. Okay, two non-zero digits, so here also non-zero, here also non-zero. They are, we can say it is one word, very interesting word, that is called trapped. If we have seen trapped zero in one place, so that should be significant. So 1 2 3 4 5 6, here the significant figure is 6. Okay, if I am taking decimal, that is assume 3.002. okay, so here 3 non-zero, 2 non-zero, and these two zeros are trapped in between these two non-zero. Whether there may be decimal or not, we are not gonna interested about that. That should be significant. So here total number of significant figures is 4. If it is 51.003, okay, here also see number non-zero, it is also non-zero. So here this trapped zeros will be significant. 1 2 3 4 5. So here significant figures are 5. Simple thing. Okay, it is not a very high level problem you have discussed. But one thing you might be thinking, sir, it's very easy then. But there are also many more problems are there in significant figures. Okay, and that's why the question is asked in NEET JEE several times from significant figures, and believe me, 60 to 70% students have done wrong. The question has come from significant figures in NEET or JEE main or advanced. Advanced it is not coming more often. It's coming in JEE main and NEET. NEET it is definitely coming. But most of the students, 60 to 70% students have done it wrong. So see each and every rule, what we have seen here, what we are doing here. So second rule is understood. Now third one. From here you can say the level of confusion is increased. The first confusing level is end zero. Okay, end zero problem. If a number is ended by 0, that time whether the 0 should be taken as a significant numbers or not, because here we have seen if the 0 is trapped in between two non-zero numbers, that should be a significant number. But if a number is ended by 0, assume 868400 or 86.02, I'm sorry, 86.0 or 8, everything is coming by 8, 2.20 or 2020. Okay, whether in this case we have to take the 0 as a significant numbers or not. Here some rules we have to take. What is the rule? Now end 0, that will be significant. End 0 that will be significant if it is at end and after or before decimal. Okay, if a 0 is at end and it is after or before decimal, then it should be taken as significant. It should be taken as significant. And if at end 0 is there without decimal, or understandable decimal, then it is insignificant. Now you may thinking, sir, what you have written, I can't understand. What gibberish thing is going on? Okay, I'm coming step by step. First step, it is told if it is at end, it is means the 0 is at end and after or before decimal, that is significant. Coming about a number, assume if I am talking about a number 86.0. Okay, whether this 0, the end 0, is significant or not, that we will see. How we have to see? If it is at end, yes, this 0 is at end. First condition is proved. If it is after or before decimal, yes, it is after decimal. So, two condition is fulfilled. It is at end and it is after decimal. Then this 0 is a significant number. So, here the significant number is 3. Here the significant number is 3. If I am talking about the next number 2.20, here you see if it 0 is at end, yes, 0 is at end. If it is after or before decimal, yes, it is after decimal. It is not telling that after means immediate after. After means it can be after any point. You can take it is 2.22345. Here this is at end, yes, and it is after decimal. So here this 0 is significant. Here also this 0 is significant. End and after decimal. Two things you have to remember. End and after decimal. So it is 1, 2, 3. Okay, and here it is 1, 2, 3, 4, 5, 6, 7. Clear? Now, one example I have given. If I have written a number, assume 24560 point. Okay, point is given here. Okay, after point nothing is there. Whether the 0 is significant or not. Here, if we see, it is at end, yes, and whether it is after or before decimal, yes, it is immediate before. Take my word, before decimal means immediate before. Yes, it is before decimal, and that's why 1, 2, 3, 4, 5, that 0 is also a significant value. Now you can say, sir, everything is significant. Now we have to go to the last. 8400. Any decimal is there? You say no. 0 is at end. Yes, 0 is at end. Any decimal? No decimal is there. So this 0 is insignificant. Achha, if this 0 is insignificant, talking about this, then if it is insignificant, you see, very interesting thing. If it is insignificant, we are not thinking about this 0. We are thinking about the previous 0. So that is the last then. And at last, it is also no decimal sign. So that 0 is also insignificant. So here, number of significant digit is 2. Here 2020, 2020. the year now. Okay, coming to the point 0, it is at end. Whether any decimal, we have told if at 0 is at end and there is without decimal or understandable decimal. Understandable decimal means this number I have written 24560, I have given a point here. If this point is not given also, the digit is same, it is not changed, but we understand that there must be a point at the end. And in this case, if the point is not given, then this 0 should be insignificant, then its significant number is 4. Here also, if I am talking here, no decimal point is there, or we can say that there is understandable decimal, that there might be decimal, but no decimal exactly there, so we can not take it as a significant number. So here the significant number will be 3. Now you may ask, sir, what about this 0? If it is insignificant, you see 2 and 2, this is significant. 2 and 2, this is significant and non-zero. Definitely it will be significant. Definitely it will be significant, because in point number 2 it is told that all zeros between two significant non-zero digits are significant. Okay, now let's see one another example. Assume 86.000. What is the number of significant figures here? Let's see. What is the number of significant digits here? How do we understand? So, end 0. Yes, the end is 0. Okay, end is 0. Whether it is after decimal or before decimal, yes, it is after decimal. Okay, so after decimal means this 0 is significant. This 0 is significant, because at last whenever we have to see, you see it is at end and it is after decimal, so this is significant. Now what will be this 0? That is a big question, but the answer is very easy. See, this is significant, this is also significant. We have already told in part 2, in rule number 2, that all zeros between two non-zero digits or two significant digits. Two significant digits here, 8 is also significant, 0 is also significant. So these two zeros are trapped, and we know trapped zeros are significant. Okay, so 1, 2, 3, 4, 5. 5 significant figure. Okay, so if you see step by step, it is very easy. Okay, so what we have seen here, all non-zero digits are significant. We have seen all zeros which are trapped in between two non-zero digits, they are significant. It is also right. End 0, when the problem has come, that is for end 0, and for end 0 it is, see, that if it is end and after decimal or before decimal, that will be significant. And if it is at end and there is no decimal means understandable decimal. Okay, in that case that 0 is insignificant. So if I have told it is 864, okay, 864 I have already done, 0 0 0 0 0 0, many zeros are there. How many number of significant figures here? You will say, sir, it is only 3. Yes, definitely, because this 0 is insignificant. If this 0 is insignificant, so nearer to it, it is also insignificant. It is also insignificant. Only 864 is significant. So here, significant figure is 3. Okay, I think it is clear enough. Now we'll go for rule number 4. You will think that, sir, till now rule is there. Yes, little bit of rule. Okay, so I'm erasing this one. This 2, it is needed to be. Rule number 4 is very easy. Very easy. Rule number 4 tells us initial 0 is insignificant. It's a very easy one. If you have written a number 0140, how many number of significant figures are there? You see 0 is at end and 1 is at decimal. So 1 is at end, 0 is at decimal, 1 is at decimal. So 1 is at decimal. 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 no decimal point is there, that means understandable decimal, so it is insignificant. This 0 is starting, so it is insignificant, so number of significant figure is 2. If it is coming 0, 8, 2, 3, 4, okay, or 0, 0, 8, 2, 3, 4, here also starting 0, initial 0, insignificant. Significant figures are 4, 8, 2, 3, 4. If it is written 0.0012, here also these zeros are initial 0, whether it is decimal or it is not, we are not bothered about that. Whether it is decimal or not, we are not bothered about that. Completely these are insignificant and only 2 significant figures are there. Okay, so this is for initial 0. For initial 0 it is insignificant. Number 5. Number 5 is also very easy. Power of 10 is insignificant. Power of 10 is insignificant. Okay, how? If I am telling a number, assume it is 2.34 into 10 to the power 6. 2.34 into 10 to the power 6, what will be the significant number here? The significant number will be 3. This 10 to the power 6 is insignificant. If it is coming 2.340 into 10 to the power 6, how many significant figures are there? Here also 10 to the power 6, it is insignificant. Okay, so we will not take it. 2.340, and here in this number ending 0 is there, and when it is ending 0 we have to use this two law. Which one is followed by it? It is ending 0. Yes sir, it is ending 0. Whether it is after decimal or before decimal? Yes, it is after decimal. Decimal sign is there. Definitely this is a significant number, so it is 4. Okay, if we have seen some more example, assume it is 5.030 into 10 to the power 3. Okay, what will be the significant figures here? So it is clear sir, 10 to the power 3, there is no significant figure. 5.030, two zeros are there, so whether it is significant or not, let's see sir. This 0, yes sir, it is significant because it is ending and it is after decimal, and this 0, it is trapped in between two significant figures, so this is also significant. 1, 2, 3, 4. Okay, if I have told whether 2 into 10 to the power 2, how many significant figures are there? You will say sir, 10 to the power 2 is gone, 2 it is 1. But if I have written, see, I have already discussed the examples also, and here examples are much important. If I have told 2.0 into 10 to the power 2, 2.0 into 10 to the power 2, then you see sir, 10 to the power 2 is not needed, but here 0 is there. Is it is ending? Yes. After decimal? Yes. Then it is 2. If it is 2.00, then it is 3 because it is ending 0 and after decimal, so it is significant. And as this 0 is significant, so this 0, the second 0, is trapped in between two significant digits, so it is a significant number. It is 3. If it is 860 into 10 to the power 5, so 10 to the power 5, insignificant. 860, when we are talking about 860, so here 0 is at end. Yes sir, it is at end. Is there any decimal? It is after or before sir? There is no decimal, so it is insignificant. So number of significant figure is 2. If it is 8600 into 10 to the power 3 or 10 to the power 4, 10 to the power 4 is not. This 0, it is n. but there is no decimal point. It is not after or before decimal. It is insignificant. As it is insignificant, this is also insignificant. So here is also significant figure is 2. Okay. So if you see the steps, it is very easy. These 5 rules you have to remember. If you remember these 5 rules, I think you cannot there should not be any problem to do any problem to finding the significant figures, and from here you will get 1 or 2 short questions in your exam. Okay, next, last rule. Someone it is told as rule number 6. Somebody it is told it is last rule. It is if I am talking about that finding significant figures, it is not a rule to finding the significant figures. These 5 rules are enough to finding the significant figures, but last rule tells us, the last rule, that constants have infinite number of significant figures. Constant have infinite number of significant figures. What is it? Constant have infinite number of significant figures, or we can say pure number. It is also for same thing. Pure number have infinite number of significant figures. What is the meaning of it? Just now I have told now that to give you an example, I have told that I have brought 10 mangoes. Out of this 10 mangoes, 2 are rotten. And then how many mangoes are with you? 8. If it is told you that how many significant figures are there, you will say, sir, simple thing, 8, 1. I am telling it is wrong. You will tell, sir, just now you have told. I have told it to make you understand the significant figures, but this is wrong. When we are talking about 8, in this number there is no doubtful number or uncertain number is there. 8 is confirmed there is 8 mangoes are there, and as it is a pure number, its significant number is infinite. Which one is a pure number or a constant? Significant number is infinite. We all know Avogadro's number. In chemistry we have written Avogadro's number. We all know it is coming 6.032 into 10 to the power 23. Okay. So if it is asked you, sir, how many number of significant figures are there? You will say, sir, 10 to the power something, it is insignificant. So cut it. 6.0326 is significant, 2 is significant, so 0 is trapped in between that. Significant 1, 2, 3, 4. You will write 4 significant figures. I will give great cross mark with a big 0. Why? So we have followed all the rule, but here there is a drawback or exception in the rule. As it is a constant, it is mentioned, it is Avogadro's number. Here we have to take it is a constant value. So here the number of significant figures is infinite. Speed of light. Speed of light. It is 3 into 10 to the power 8 meter per second, whatever it may be. If I forget about the unit, 3 into 10 to the power 8. Number of significant figures, you will tell, sir, 10 to the power 8, forget about it, it is insignificant. 3, it is only the number, so significant figures will be 1. I will say it is wrong. As it is a constant, its significant value is infinite. Then you may ask, sir, how do we know which one is constant and which one is not constant? Simple thing. If it is a constant, it will be mentioned there. If it is given that the speed of light is 3 into 10 to the power 8, how many significant figures are there? It should be infinite. If it is given in general that it is 3 into 10 to the power 8, then you can able to find the significant figures. But if it is mentioned that it is speed of light, we cannot use. If it is mentioned that refractive index of a substance with respect to some air or something, so refractive index of glass with respect to air, I think it is 3/2, that is 1.5. If it is asked you then how many significant number is there, you will say sir 1.5, it is 2. I'm telling it is wrong, because it is mentioned refractive index and it is a constant value here also, infinite. The value of pi, the value of exponent, okay, some exponent digits you have taken, it has coming a value. All these are constants, and if it is a constant, then number of significant figures are infinite. Okay, so this is the first idea of significant figures, and we'll then go for the rounding off. Okay, and I'll give you a DPP. There are some examples I'll give to you, okay, for exercise. Some questions I'll give, you will do it. Okay, I think the laws are clear enough. Okay, next we will do rounding off.